Hello, my name is Nathaniel Enhard, or Nathan, and for my remote sensing project, I have chosen to look at vegetation in the Endicott Arm in southeast Alaska. The Endicott Arm Fjord is approximately 30 miles long, and it trends east to west. In the west, it terminates into Stephen Passage, an important part of southeast Alaska transportation, and in the east, it terminates with Dawes Glacier. It is a popular cruise area for cruises out of Juneau, Alaska, and for this project, it's especially good to note that as the Dawes Glacier retreats, we can see the process of vegetation reclaiming the areas that were once glaciated. In order to properly look at the vegetation in this area, I have taken Landsat-A imagery from the USGS Earth Explorer website and selected different bands of the image, which represent different spectra. When bands 5, 4, and 3 are loaded as red, green, and blue colors respectively, we can see what is called a near-infrared or NIR image. For Landsat-A imagery, band 5 represents infrared spectra. Therefore, if we select band 5 as the color red in ENVI, we can see that spectra as a red color. This allows us to see such things as vegetation, bedrock, ice, snow, and water in varying colors. If we choose to load our NIR image in a grayscale scheme, we get this NDVI image to the right. In this case, the brighter location is, the more healthy and dense the vegetation we have in that area. This NDVI image allows us to really distinguish between the vegetation and water and ice. In fact, the lighter stripes that you see in the Dawes Glacier represent the areas where the glacier accumulated rock along its way to the water. In addition to this, if we look closely, we can see that some portions of the water in the Endicott Arm are lighter or darker than other parts. This is most likely due to a high volume of sediment entering the water from the glacier. Finally, the southwest quadrant of this image seems to have a lot of dense, healthy vegetation on the south-facing slopes. A possible explanation for this is that the slopes are more exposed to sunlight and the warm front rains that come from the southeast. If we move back to our NIR image, we can classify the infrared pixel values. The colorful polygons all represent instances of different terrain. The bright green represents vegetation, the light blue is silty water from glaciers, the royal blue is other water, purple is the exposed bedrock, magenta represents the dirty snow or ice, white represents the clean snow or ice, and the darker green represents areas of lesser vegetation. After drawing these polygons, we must then choose different classification schemes that best fit our imagery. For this project, both minimum distance and maximum likelihood were chosen and compared to see which one represents our study area best. The minimum distance classification scheme classifies the unknown pixels closest to our polygons using their mean or average vectors. With maximum likelihood classification, the program assumes that the pixel values are normally distributed within the polygons and assigns a class to each pixel based on the highest probability. If we look at our minimum distance classification, we can see it doesn't really look like anything like our NIR image. According to this image, we have a massive amount of dirty snow or ice in the center of Endicott Arm, while the Dawes Glacier is actually made up of sparse vegetation. Even after limiting our classification down to 4 classes, the minimum distance images still didn't look like the actual study area. When we look at our maximum likelihood classification, it looks much more like our study area. Using 4 classes, vegetation in green, bedrock in purple, water in blue, and snow and ice in white, we can actually gain useful observations. For instance, the water looks like it's cut in half in the west by bedrock. However, this just represents the silty water that we've discussed earlier. Likewise with Dawes Glacier, the large amount of bedrock we see is in this classification compared to our NIR or NDVI images is due to all of the rocks and sediment that the glacier has accumulated over its lifetime. Finally, it seems that there are areas of scattered vegetation within the upper altitudes among the snow and ice in the northeast quadrant. While this may seem counterintuitive, one of the first types of vegetation to grow when a glacier has receded is a type of plant called sphagnum moss. It's found all over southeast Alaska. While this does seem unlikely, it is certainly possible that this type of vegetation is actually present and has not been misclassified. While our generated confusion matrix is technically a misleading type of data, we can still observe how well the ENVI program has classified pixels according to our classification and estimate how much of the image each classification takes up. One positive part of this confusion matrix is that for each classification, no more than 10 pixels were classified incorrectly. Building upon this, we can observe that approximately half of the study area is still covered by snow and ice. In addition to this, one of the most surprising observations we can see from this confusion matrix is that vegetation only covers an approximate 11% of our study area. This may be another misleading statistic and may be misclassified, but more research must be done to confirm this. To summarize what we've observed in this presentation, the maximum likelihood classification scheme yields the most accurate results. However, these results may be suspect and are not final. Second, approximately half of our study area is still covered by ice and snow. In addition to this, areas of vegetation are observed all the way up to higher altitudes among the snow and ice, most likely in the form of mosses clinging on to newly exposed bedrock. Finally, vegetation tends to be the healthiest and most dense on southern-facing slopes, which could be explained by the rain-bearing southeasterly winds and warm fronts that southeast Alaska continuously experiences. Thank you.